All right. We said we will talk about E9. E9, it says create a VI that continuously generates a random number. Yeah, so it should generate a random number between 5 and 7 each 100 millisecond. To show the result, numeric indicator, VI stops with a stop button, and here it gives you a hint. Okay, so this is my code. Let's put this here and this here. Now it says each 100 millisecond and stops with a stop button. This means I need a while loop and like this. Okay, so this is straightforward. The random number is here. This is your random number, right? All right, so this generates a floating point number. Now we need to be familiar with this floating point meaning. It means fractional. Okay, it's not integer. Whenever you hear floating point number, it means fractional number. Okay, you can use the decimal dot, the decimal place dot. Okay, so this generates a DBL or a floating point number from 0 to 1. It means your values can be anything between 0 to 1. Okay, now what I need, the question says map these to become from 5 to 7, right? It says 5 to 7. Okay, so how okay, Shabab, do you hear me? Muted, why? I did not mute. I don't know why it mutes. Sorry about this. I don't know where. Someone has muted me. Guys, if you don't want to hear what I'm saying, which is not okay, then you close the speaker from your side. If you mute me, the rest will not see. Now clear? Okay. All right. So I don't know where you following, at which point. So I'm going to repeat this trick. Okay. So you have a floating point number. It's a random number from 0 to 1, and you need to map this to make a change from 5 to 7. Okay. Now you do what we call linear map. Okay, Shabab, is the font clear to you? I'm not sure how you see things from your side. Okay, so
Mr. Ali, you're muted again.
Yeah, but someone is muting me. Why? You have been muted. It tells me you have been muted, and someone has muted me. And so this is. All right. So basically, I have what I need to do a linear map. Okay. I need to map this 0 to 1 random number to make it change from 5 to 7. So simply, if you have 0, so x equals 0, then you want y equals 7. So 7 equals b, directly like this. Second equation, if you have 1, then the result should be 7. So actually, I said here, sorry, I should be 5. Okay. So if you have 1, y should be 7. This means 7 equals 8 times 1 plus b is already 5. So you know here that a is 2. So if you multiply by 2 and add 5, then you will change, or you will map this random number. Okay, Shabab, is it clear? So you just need to build, multiply and add. Multiply this by a number and then add a constant. This is called linear map. This is straightforward.
Doctor?
Yes.
I used a different way to solve question 9. Is it okay, or you have to use this way?
Depends on the way you use. Anything outside the lab, I will not accept.
Because there's the function random from 0 to 1. There's another function right beside it. You choose the numbers between what and what.
Which one?
If you go random number, yes. If you can click on it.
Yeah, this is new actually. It was not there before.
Yeah, you can
so you tell
use
him,
a higher bound. Yeah, this is what I did. 5 to 7. Straight away.
Okay, let's agree. Don't use this one because this is new in 2019 only. I did not see it before.
Okay.
So please, please solve it this way.
Change it. Okay.
Yes, please. So multiply by a number and add a number, because this idea is practical. Practically, you will use it here and there. Okay, so it's nice to practice it. This is multiplying by making a linear operation on a number. Sometimes with sensors you want to multiply. We want to do this. So this is useful. Okay, any more question about this one? Okay, going to close. So this is E9. All right, so let's continue with lab number 2, case structure. Now, case structures are used to make conditional execution. As simple as this. So basically, in text-based, you have the if statement. Okay, if a condition is true or false or whatever, then you want to execute a code. If it is else or otherwise, you want to execute another code. Okay, so this is if-else statement is translated to a case structure in LabVIEW. Okay, now used to have which is switch case structure. Okay, so let me type here. Where's my typewriter? Okay, so basically here you have switch X. Okay, and then you tell him case X equals, let's change the location for this one. All right, like this. But then case X equals 1, then do code 1. Case X equals 2, then you can do code 2, etc. And then you end the switch case. Okay, so this is a switch case structure. You have a variable. It's either a number or a string or whatever, and based on the value, you want to execute a specific code for each value. So basically, the switch here will execute only one code. Okay, so if X equals 1, it will execute code 1, and it will skip all the rest. Okay, this is equivalent again to a case structure in LabVIEW. All right. So this is summarized here. Now the important thing to remember, which are the bold notes here is that the case structure will execute only one frame, similar to switch case in C or MATLAB or text-based languages. Sure. So the principle is easy and straightforward. Now we have something in LabVIEW. Sometimes you specify cases for specific set of values. And you said here switch x equals 1, code 1, case x equals 2, code 2. But what about if x is not equal to 1 or 2? Now in text-based, it will skip all the cases and will do nothing. Now LabVIEW, you have to specify a default case. Okay, in case your input doesn't fit to any of the cases you have built, then you have to specify a default case. Okay, so I'll see this through an example, but keep in mind there is something called default case. Okay, sure. All right, so let's do tutorial 1. At this point, you need LabVIEW open from your side. Okay, anybody has a difficulty installing LabVIEW for now, or any opening LabVIEW, any problems? Okay, so let's open a new VI like this. Front panel, block diagram. Okay, so tutorial 1. Let's get this one. Okay, it says create a VI that generates 2 different sounds using a switch control. So basically, you have a switch control. This is number 1, and based on the state of this switch control, you need to generate either high or low frequency or like a different sound. Okay. All right. Okay, so in the block diagram, if you right click and you go to structures here, you'll see case structure. Okay, now we can draw it. We don't call it a loop, we call it structure. Okay, and here directly you'll see a broken run arrow. It means, who can tell me what this means? Broken run arrow.
It means something is wrong. You cannot run the system.
Yes, either you have broken wire or you have a VI with missing input. Yep, there is no condition. So necessary input for your case structure is what you call here, it's called case selector. Okay, so here by default this is green. The color is green. It means this is Boolean. It takes either true or false. And here, if you click this drop down menu, you will see false and true. So true, you are in the true frame. We call it a frame. And in false, you are in the false frame. Okay. So whatever you want to execute, you put it inside the frame you want. Now, but here you will think that this is green, so I have to wire a Boolean. But this is not true. This is adaptive input. It means you can wire different types of data and it will adapt automatically. So here, if I wire a numeric constant, مثلا, or a numeric data, see now the color has changed and the behavior of the case structure has changed to give you numeric cases or cases with a numeric label. So here I have 0 and 1. Okay, and note here case 0, there is default word beside it. It tells you that this is the default case. Okay, at this configuration, you have configured only two cases, case 0 and case 1. But if the input is 5, so you have set 5 here, Now this is doesn't have a corresponding case. Automatically it will go to case, the default case, which is case 0. Okay, so always the default case you are doing, or you are handling values that are outside your range or not expected values. Okay. All right, same. Later on we will see string data. If you wire a string here, the case structure will adapt. Okay, so it will adapt to the string you are giving. All right. Okay, so let's keep it to its default behavior and wire Boolean. Okay, now the tutorial tells me I need to generate 2 sounds, high or low. Okay, so I'm going to place a Boolean control. Okay, like this one, and properties. Okay, so, and I have to put low and high labels like this. Okay, so on the front panel, I'll place this tile, horizontal toggle switch. Now all of them are Booleans, they are Boolean data, but their shape and behavior is different. It's just to imitate realistic switches and push buttons. Okay, so all of these are Booleans. So what I need is this horizontal toggle switch, and I'll place it here. Now before you place it, if you click and hold, you can change the size at the same time. Okay, so again, from Boolean, I'll put this, at the same time I'll click and hold just to change the size to fit my front panel. Okay, the block diagram, you see it directly there. All right, so it has a label, so I need to remove this label. If you right click and visible items, you can remove the label. Okay, instead I'll put my own labels. Okay, so I will double click the front panel and type high. This means high frequency. Double click anywhere and then give it low. Okay, this is low frequency. Now if the font is not big enough, you can double click your text, and here in this menu you can go to size and then change it to give you the proper size you need. Okay, same way I'll go to low size and 36. All right, so this is my front panel. Now here in the block diagram, I'll wire this to my case structure. Okay, now it did not adapt because it has still have some string. So you can do it like this. Now you need to retype them again, false and true. You can double click here and then type it again, false and true. Or you can delete this and put a new one like this. Okay, Shabab, are you following?
Yes, doctor.
This is my case. See here, what's the default? I don't see any default case. Why is that? We said like you need to have a default case, but with Boolean we don't see this. Can you guess the reason?
The default is always false in Boolean.
Maybe, but remember, like if the values are outside my range, then I need the default. But here, the Boolean, it's always either true or false. Huh? So definitely one of them will execute. But if you have numeric inputs, you specify case 1 and 2, and the input is 5, then you have to specify default case. So basically here, this is not required. Yani always the value here will be corresponding to a case, a realistic case. Okay, شباب? So another way to switch between cases, if you put the mouse pointer inside your case, hold Control, and roll your mouse wheel, you'll see now we are switching between false and true. Okay, or you can use these arrows like this. Okay, so here now if you click the switch, this is true. Okay, so in true I have low frequency, so I have to put a low frequency, a beep with low frequency inside the true case. Okay, شباب? So in sound and graphics, I'm going to use beep function. Okay, last time I've seen the beep function. I'm going to repeat it now. So the help for beep function, this is very simple. We have three inputs: frequency, you have duration, and use system alert. So it will beep, this VI will beep, it will generate a sound for the given duration of time, and at the frequency you specify. So if you want high frequency, you put here مثلا 2000, 3000. Low frequency, you put 1000 or 500. Okay. Okay, sharp. So in the true case, this is low. So I need to put low frequency here. All right. So I'm going to create a constant, another constant here, and another constant in this. And this is scrambled, this code. You don't see where each one is wired. So you just select the whole thing and clean up your code like this. Oh, now you can see this one is the frequency. So low frequency, let's consider this as 1000 and make the beep for 100 millisecond. And I don't want to use the system alert. Now if you go to false, false is empty because you have to specify what you need to execute in false. Okay, you did not put anything yet. So I'm going to copy this, Control C, go to false and paste it here, and then I'll put, I don't know, 4000 Hertz. Okay, can put anything. So on the manual here, yeah. So now if I run my VI, okay, this is low because it has executed true, but high, this is high frequency. Can you hear the beep, guys?
Yes, we can.
All right. So how many times does it execute? Okay, guys, you need to build this code from your side, and you need to answer these. Step 9, 10, and 11 is trivial. Okay. How many times does the VI execute? Anybody with an answer? One time, so if you want this to continuously execute or execute continuously, so are you following? I have a feeling that you don't understand Yeah, stopped. I'm just asking questions and modifying the code a little bit. Okay. And then I need you to answer by running your code, the code from your side. Okay. Now, okay. Each time you execute, you have one execution, and you have one execution and either true or false, depending on the switch case or the switch input. Okay, guys. Now, if you want this to execute continuously, you need to use while loop. Okay, guys. So I'm going to enclose everything like this in a while loop. And of course, you will need a Boolean stop condition like this. And then you can run. Okay, so this is low frequency.
Doctor, I have a question.
Yes.
The speaker, the green, the F, if you make it T, what will happen?
Then you will hear system alert. System alert اللي هي the Windows sound. This one. Like this.
Okay.
Can you hear?
Yes.
Yeah. So sometimes in your code you want to notify the user that something is wrong or something. You need to audibly notify the user by giving him some sound.
Okay.
Yeah, you can generate this frequency or use this. So for us, because if you put true here, these are useless. Okay, so I want to generate high and low frequency, so I need to put this as false. Okay. Okay, guys. Okay, guys, you understand case structure? Should I repeat any point?
I have a question, Doctor.
Yes, go ahead.
Can it be more than 3 cases? More than 2 cases?
Yes.
But how will use high and low the button على اليسار?
For this, the question tell you either generate high or low. صح?
Yes.
So basically, you just Boolean is enough to solve this. Okay. But in some scenarios, you want to tell him مثلا high, low, medium. شو رأيك? Now, high, low, medium, Boolean control doesn't work. يعني because it's 2 cases only. صح? So you need to use another control. Now for that, maybe it's early to give you this now, but okay. Either use what you call enum or a ring. Enum or ring. Enum is very simple. It's a number, and you specify labels here. And tell him high. دقيقة شوي. You specify here some cases. You tell him I want high. It's early to I think this will confuse you now. High, medium, and low. Okay. So this is like this. It's called enum. So now I remove my Boolean and put this enum like this. Now see, now this has 3 cases: high, medium, and low. And here in the case structure, you have 2. So you tell him add case for every value. So now you have 3 cases: high, medium, and low. So you have to rearrange your things here. In the high, I want high frequency like this. Okay. In the low, let's consider this as low. And in medium, I want مثلا ما أعرف 2000 like this. Okay, so now if you run, this is medium, this is high, and this is low, like this. Okay, if you run it like this way, you can put a number here. It's just to show you that you can have more than one case. The details of what I'm doing, we will deal with this later. So you can put here a number. So case 0, consider this as low مثلا. Case 1, consider it as like high or whatever. Case 2, you can consider it like this. Okay, and you can add as much cases as you need. So مثلا I want one more case, so I tell him add case after. And مثلا you can put 10. They don't have to be sequential. Case 0, case 1, case 2, case 10. Okay, depends on your what is generating this number actually. Okay. So the answer is yes, you can have as much cases as you need, but for each scenario you have to put the proper input to the case. Okay. We'll come to these complications later on. Let's stick to the Boolean now. Okay, is that an answer or still?
Yes, clear. Thank you, Doctor.
All right. Who else? I think Kareem. Yes.
I have a question. How when we were doing the high versus low button, how do we know if high is true or false, and if low is true or false?
Very good question. So by default, when you place the control, see, this is the control, right? When I place it like this, the default position is the false. Good.
And that's always the case.
Yes. Any Boolean you place, rocker like this, vertical switch. Okay. Always this is the false position, the mechanical position.
Okay.
So مثلا you said I want the false, which is this, the default, to be low, and the true, which will be here to the right. This is the high. Then you have to reverse everything here in your case, because the way you put things, you arrange things, that if you press, this is true, this is high. Yani in the true you have to put the high, so this has to be 5000, and the default location, you said this is low, then you have to put this as low. So it's your selection, but the thing is that the default position is the false. Yeah, is that?
Yes, makes sense.
Okay. Why did I place this right left? It's just a choice, and you can put this like this and this like this. So this is just convenience. Okay, more questions? All right, so case structure is very, very simple. For now, I have explained just the true false. The rest we will do probably next lab, or maybe in the assignment, but I have to give you a hint for this. But at least we know the behavior. Okay, more complications will come later. Now, one question here is that when I run my VI, is the sound coming continuously, like one wave, or in a discrete way? You see now, it's like there's a delay between each beep, right? Okay, it's like there is a wait function or a delay between each beep. Now the reason for this is because of the behavior of this beep VI. Because each time you execute the beep VI, the computer has to connect to your audio hardware, generate the sound, and disconnect. So this disconnect will take some time. Okay. So this is why you hear this like in a discrete way or بشكل متقطع. simply because of the overhead. We call it hardware overhead execution for this beep VI. Yes, right? All right. Now here it says try to make the duration of the beep 5,000. Yani 5 seconds. Okay, question? Yeah, it will affect. Yes. You'll see this later on, inshallah. That's a good question. Keep it in mind. It will add extra time to connect and disconnect. We will measure this in the next tutorial. We will measure this time. Okay. Now, if you make the beep very long, so here 5,000 and here 5,000. This is the duration, by the way. If you point to this terminal, automatically you'll see a label. This is the duration. So I'm beeping for 5 seconds. So each time, $5 seconds, and you hear a cut, then 5 seconds, a cut. Okay, now if you stop, you see now the stop has delayed. Yani it has taken long time in order to stop your VI. Okay, can anybody guess why? The VI is not responding directly. You see, the stop it did not take it directly. It has to take time in order to execute. Anyone can guess why it's taking so much to stop, so much time?
The stop causes the iteration to be the last one. So depending on the length of the iteration, it would take some time. So.
Yes, that's the answer. But because the iteration did not end. Yes, you are okay. This is a good answer, but one more question. See now, it's beeping. Okay, it's taking its time. If I stop now, it has beeped again, صح? Yeah, it should finish the current iteration, right? But instead, it finished the current iteration and went to the next. Anyone can guess why? This is a tricky way to understand how LabVIEW is executing. All right, let's analyze how LabVIEW is really executing. Yep, let's see an answer. 2 loops. Okay, not really. Of course, because you have a while loop. Okay, there's two things. Okay, it's either executing true or false, and while loop is it's just doing its iterations. But the main reason for this is the following. Now, once I run, how LabVIEW will see is the following. Now, is there any wiring between this chunk of code and the stop condition? Okay, let's maximize this. Don't see any wiring between this code and the stop condition, right? So practically, LabVIEW will read the value from Boolean here. At the same time, okay, it will read the value from the stop control, right? So this is, say this is true at the beginning. Let me take this to one note actually to make things easier. Okay, نكبر شوي. All right. So say LabVIEW has read some value here, and say this is true. All right. And here, at the first time you executed the code, the stop button was not pressed. So this is false. Consider this as being false. Okay, So since this is true, LabVIEW will go directly to the true case, and it will execute whatever is happening here. But this is taking so long time. It's taking 5,000 milliseconds or 5 seconds. Okay, 5 seconds. Now during these 5 seconds, what's going on? Now LabVIEW is doing this alone. There's nothing else to do. So basically, if you press this boolean during these 5 seconds, LabVIEW will not see directly the result. It will latch the result. Okay, if you go here to the front panel and I execute again, now if I run, you see LabVIEW did not pop out this control until the next iteration. Okay, so this kept like true. Okay, when I pressed it, it has held its value. We call it latch. Okay, until it has finished beeping this. Okay, and it will not stop directly because it has already read this value at the beginning of the iteration. But when I pressed it, it was read and done. So it will latch the value until it finishes this next iteration and go back. It will go back, see the value you are giving here, whatever it is, it will execute. And already this is latched from a previous iteration. And here you will see true value. Now this is true. It will not terminate directly. It has to go here and beep for another 5 seconds. And waiting to finish this beep until it's terminating the while loop. So this is how it is. So once you press the stop button, it depends. If you are already busy executing something, LabVIEW will not respond directly. It will latch the result and hold it there until it finishes everything, go to the next iteration, and has the enough chance to come back and read your latched value. Okay, Shabab? I don't know, how clear is that? Anyone with a question? All right, so let me repeat. Okay, so what is happening here is due to latching action of this Boolean control. Okay, now the thing to keep in mind from all of this is that LabVIEW has to have the proper chance to read the value from your control here. Okay, now if you has already read this control, which is what's happening here, I'm reading this control. Okay, and doing the case taking so long. If you press this control while the beep is generating, you will not see the result immediately. LabVIEW will latch the result. Latch, yani it will hold. It will hold and keep it in mind until it finishes the iteration and has the enough chance to come back and then read the last value. Okay, Shabab? Okay, so this is just a note on why you don't have a responsive front panel if you put a high delay here. Okay, again, so you see now it's latching the value. Next iteration, it has read the value. When LabVIEW reads the value, it will pop out. This Boolean will pop out again. Okay, so what happens if I press and then run? Now, if you press and run, you see LabVIEW has read directly this control and popped out its value. So it has finished at one iteration directly. Okay, so if you press and run, directly it has popped out. But if I press now, nothing happened. And LabVIEW did not pop out this Boolean again. It means it did not read. LabVIEW did not have chance to read this value. Whenever you read the value here, it will pop back to zero, to false. Okay, Shab, I don't know, is that clear or tricky for you? Okay, Keep it in mind. Later on, we will investigate this, what you call mechanical action of the booleans. What LabVIEW does to latch or to switch. Okay. Okay, so this is to answer step number 10. So anything unclear about the case structure? Any questions from your side? All right. So now let's go to flat sequence structure. Now, the case structure simply will give me a case switch equivalent or conditional execution, something called conditional execution. Depending on the condition of an input, you will choose a subframe of your cases. Okay. Now, I want to execute things in a sequential fashion. Okay. What do you do? Previously, we have seen an example when you have wiring between VIs. Let me give you another example for this. Okay, let's have it from the Arduino toolkit. Okay, this is my Arduino. Let's close this. When I communicate with Arduino, I often has to initialize مثلا read analog pin and then close. Okay, now this is typical way to use these VIs, and you have to wire the output of each VI to the input of the next one, like this. All right, now this way, if you wire VIs this way, you have made some data dependency between them. All right, so this means that this first VI, it has to finish execution and give a value through these wires to the next VI. This has to finish execution and then give value through this, etc. So here wiring has forced a sequential execution into your functions or VIs. All right. Now these VIs, they require this. They require you to wire them together. Sometimes you don't have a chance to wire them, or they don't accept values from each other, but still you need to make sequential execution. Okay, so the question is, I don't have wiring, I cannot do wiring. How can I force sequential execution? The answer to this is using flat sequence structure. Okay, so this simply they will execute code sequentially without wiring. This is what they do. So these are easy. All right. Now let's take this example. I want to create a VI that beeps 3 times after each other with different frequencies. Okay, so let's begin like low, medium, high. Okay, so here what in the example it says, okay, I have high, low, and medium. Okay, let's do the same. So to do this, I need a flat sequence. So I'm going to select this one. This is my flat sequence. Okay, now if you place it like this, automatically you have 1 frame here. So this looks like a camera film. Okay, it's just simply to tell you that this is like frame by frame execution, similar to cameras. Okay, now to add more frames, you right click the border of your sequence and then you tell him add frame after. So each time you want 1 more frame, you tell him add frame after, depending on your number of frames. Okay, so here I have 3 frames to do 3 things sequentially. Okay, let me do this. All right, so I need 3 beeps. So what I will do is take 1 beep function. Okay, I'll place it here. Okay, control drag and then control drag. So I have 3 copies of this. It says let's generate at the beginning. I don't know. So in the manual, let's stick to the manual. Okay, so we have 2000 hertz. I'm gonna copy this, and I need 1000, and then okay, so this is the frequencies. All right, so the duration is the same for all. I'm going to create a constant and put 100. Same here and same here. Okay. Do we want to use system alert? I don't need the system alert, so this is false. Control drag like this and control drag like this. Okay, so in this way you have 3 frames and you are forcing them to happen sequentially. Okay, why do we use the flat sequence? Is simply because you don't have wiring between these VIs. The beep VI, you cannot wire them sequentially. They don't have any data dependency. Okay, so this is the only way to make them or to force them to happen in a specific order you want. Okay, so this is simple. Now if you run, okay, it's very simple. All right, so here if I want to change the duration, you see I have a trick. You have to come here to this, make it to 200 and change it to 100 here and change to 100 here. Okay. All right, so does it make sense for you? Do you hear the sound?
Yes, we do.
Okay, guys. So this is flat. Now, okay. Okay, so now 2 things. Here, the duration is common for all the frames. Okay. Now, you have just seen that if you need to change the duration for all of them, you have to come at each one and then change the duration, the next one, and change the duration, etc. So since this is a common input for all of them, you can simply put it outside your loop like this. Okay. To delete everything. So these are common inputs for all of the frames. Okay, so you can place them at one location, which is outside the loop or outside the sequence, and then wire them directly to each VI like this. So I'm going to delete these. Okay, and I'm going to wire it this way. Like this and like this. And this is false, it's common for all. Like this, and right click, let's clean up. Okay, and then this is this. Okay, so see now we have one common location to change the duration for all of these frames. Okay, the frequency, it's variable, and each frame has its own value, so I cannot put a common value. So see now, like each time you need something constant, like common for all frames, you don't have to place a copy of that constant. You can put it outside at one common location and change from that location. Okay, so if I change the location, the duration now, you just change this and it's common for all. All right, so if I put 100, that's enough.
Mr. Ali?
Yes.
Can you please repeat how you took the common factor outside? Because when I did it on my laptop, it showed me a broken arrow.
Ah, good. You already created that constant, right?
Yes.
Okay, so and you have constants. Let me repeat, okay? You have constants like this inside. This and this. Yes, this is your case, right?
Yes.
So here we have 100. Let me repeat this for all of them. Okay, 100. This is how we did it at first time, right? So let's arrange this, arrange this. You see now what I'm doing? I'm just cleaning my code. Okay, now it's clear. This is false and this is false. Now, if you place them outside, just like this, drag them, automatically have a tunnel, right? You agree about this? You just
okay,
drag
yeah.
them.
Yeah, okay, it works fine.
But now the tricky thing, you can either wire from here. You see those? I will delete those. All right. Now, Control B. I remove the broken wires. Now, if you wire it like this, what's happening? You have created another, what you call tunnel. We'll come to this. You have created a tunnel between these two frames. Okay. Now, in general, we want to avoid this. We don't want to create tunnels because, again, here you have tunnel. So for this constant, you have tunnel, tunnel, tunnel. Okay, that's fine. But what you want is to specify that this is just, we need a tunnel for directly the frame itself, not through another frame. Okay. So here, another way, you can create it like this, even though the wires are broken. And then here, I will take it from here. All right, so this is here. Tamam?
Yeah, okay, fine.
Okay, so I'm just going to arrange my tunnels. Okay, so why this way? Okay, this means that the value for these two constants are given directly to this frame, and you take a copy of them or another route and directly give it to this frame. Okay. Now, if you use this way from here, this is fine, but in general, the data is outside. Why should I pass it to a frame and from frame to another frame? It's not good for style. Okay. So if the data is directly given to the frame like this, it's more readable. When do we need this? When you pass from frame to frame, is to give a result from here. If you execute from here, the result from this frame, you want to pass it to another frame, then okay, you can pass it this way. Okay, so, all right, so this is this, and okay, so you understand this part? Should I repeat anything? Okay, let me just arrange my tunnels because I want them to look more readable. This is not good readable. All right, this is more obvious. Okay. Okay, guys. If you want to clear up the whole code, you can just press this cleanup utility. Okay. So if you clean up like this, LabVIEW will shorten the size of this code. But sometimes it's not good because your mind will, you are following this scheme, so you may want to clean a subpart of your code or subcode. Just select that one and then clean up like this. So the style is something you can do anytime. Okay. Don't need that, so let's shorten this. You can triple click any wire, and then this will select all the branches of this wire. Okay, so if you triple click, right click, and then clean up wire. Okay, now this is better. So I'm going to triple click, go here, and then clean up the wire. All right, this is much better. Okay, so clean up, and then clean up. Okay, so this is this. Now tunnels, we'll discuss them the next topic. But now, let's see another tutorial on flat sequence. Now I know now how to execute things sequentially. Okay, this is very easy. Now we'll use this in order to measure the time a code or a subcode or a frame is taking. Okay, so here you have 3 beeps. This one, and this one. Okay, now I want to measure the time between the first beep and the last beep. Yeah, the time it takes to generate this, and this. Okay, sure. So theoretically, or if you calculate it here from the delay, what's the time taking to generate 3 beeps? Since this is happening sequentially, then the overall time is the time taking to execute this frame plus this frame plus this frame, right? Whatever is inside them. ليش 4.5? Each one is taking يلا عدل الإجابة يا محمد. 0.3. Okay, that's correct. This is what we expect, right? But remember, we have said that there is hardware overhead. Okay, and does the hardware overhead affect? Yes, Nawar. Now this will affect, and you'll see why. Now to measure the time, this is taken. What you'll do, use timer. Okay. Now we'll use the timing VIs, but we will use a tick count VI. Okay. So this VI is very simple. If you enable the help, you'll see it returns the value of millisecond timer. So internal timer in LabVIEW is already started, and this will return the value of this timer. Okay. The timer is hidden. You don't have to initialize, start, or stop. You just read the value of that timer. Okay, so it's very easy to use. If you place it outside, you see now it has just one output, which is millisecond timer value. So what I want to do programmatically, I want to read the value of this timer before executing anything. I have to read the value first, execute, and then read the value again. And by calculating the difference between them, you will find out the overall time taken by the whole code. And this is valid for everything. Okay, it doesn't have to be like 3 cases. It can be whatever, case structure, while loop, whatever. You just read the counter, do something, and then read the counter again, or the timer. Okay, so what I'll do here, you have to place another frame, but now I will add frame before. Okay, so this is my frame. Now inside this frame, what I will do is read this value. And after I finish executing everything, okay, again, this can be 1 frame, 2 frames, whatever. At the last frame, before you finish, you want to add 1 more frame to read the counter again. Okay, sure. Now I need to find the difference. How do I do this? Okay, it's very simple. Here, you will wire this to a tunnel outside, and then you can wire this again using a tunnel. Okay, so here I'll put subtract VI. I'll tell him the counter value at the end minus the counter value at the beginning. This is the time between start and end. And then I'm going to create an indicator like this. Okay, so let's call it DT in milliseconds. Dasha, you understand? So what will happen? You read this value and then store it at this tunnel. Okay, and it's stored. خلاص. After you read the value and everything is done here, it will go to the next frame, beep for 100 milliseconds and wait until you finish the beep. Then it will go here, beep and continue beeping and for 100 milliseconds. Same here, and then read this timer or this time counter and store this in a tunnel. After it finishes, it will yield the value here. It will send this value and find the difference. Okay, already here from the first frame you have a value. Okay, شباب. So this method you can call it T0, and this is T final. Okay, so here you calculate T final minus T0. This is what will be calculated. Sure. You can see now how I can place a comment. Just double click and tell him this is T0, and then point to anything you want. Okay. Shall we understand? Anybody doesn't understand this part?
Doctor, I have a question.
Yes, please.
الحين the timer, once you run the system, they both start at the same time?
No. Why?
Why?
Well, because these frames, you are in the first frame, صح?
Yes.
All of the other frames will not do anything. They are waiting until this finishes. Okay. Now, when frame 1, let's call this frame 1. Now, when frame 1 finishes, everything inside it, then it will go to frame 2. Okay. Say this is taking 2 seconds. What about the rest of these frames? They will be waiting. They will not do anything. So basically, finish frame 1, everything inside frame 1, then finish frame 2, then frame 3, etc. Okay? Understand? So while the frames are executing, and while frame 1 is executing, all of the other frames will be waiting. They will not do anything. So you know now that this counter will be waiting until everything is finishing. So all of the frames are taking their time, okay? And the counter is internally inside LabVIEW, it's hidden from us, is internally increasing, okay? So all what you do here is to read the value of that timer. Okay, sure. You understand?
Yes,
Abdullah?
Yes.
Yeah. Is that clear to you?
Yes, thank you.
All right. So now when I run, what do you think the value here? We said 300, right? Oh, it says 302. So it has taken 2 extra milliseconds. Oh, now it's 3, 4, 3. So it's between 3 and 4, right? Why is that? It's because of the hardware overhead. Yeah, this VI, or all of these beep VIs, like each one, should beep for 100 milliseconds, but it's taking a little bit extra time in order to connect to hardware and disconnect from hardware. Okay, so here you have this 3 ones, their effect is clear. Okay, sure. All right, any question about this example? It's very important. If you want to measure time taking and executing a subframe or a code, then this is the way you do it. You read the time at the beginning, execute, and then read the time at the end. In MATLAB, how can you do this in text-based? Because we are doing things sequentially, we can easily translate this into text code. So in MATLAB, how can you do this? Remember in MATLAB, we said T0 equals tick, right? So there's a function in MATLAB called tick. I think tick with C or with K, I don't remember. But you start a timer like this. Then let's put this as a big code. Right? It's using TikTok. There's something in MATLAB called TikTok. The question will ask you, find the time consumed in executing a VI, or the time taking to execute a frame or a sub VI or a VI. Okay, so this answers the question is to find time consumed in doing something, executing a loop, iteration of a loop, anything. Okay. All right. So TikTok, you start a timer. Whatever. Tell him code 1, execute code 1, code 2, whatever, and at the end you tell him t final equals toc, like this, and then dt will equal t final minus t0. This exactly translates to our code here below. Okay, so start a timer. This is like start timer. Okay, execute your codes, whatever code you have, code 1, code 2, and then read timer. Actually, this is start. Okay, so you read the timer again, and this is happening. Now, keep in mind that the timer is running in the background. It's hidden from us. So the execution here doesn't affect the timer. The timer is always running. Okay. All right, so this is clear. Okay. This type of question can come. Measure the time duration taken to execute code given or frame given or VI given. Okay, any question, any note on this? So all of these have been listed here, all of these things. You expect to have 300 milliseconds, but you have extra time. This is because of the connect and disconnect cycles, start stop cycles. Simply we call it hardware overhead. All right. Now, if you want, there's another counter here in the timing subpalette. You have high resolution timer. Okay, this will give you a better resolution, and you can measure time in a more precise way. So if you use it this way, just copy it, put it here, and then copy another one here. Okay, let's find it using this timer. So I'll tell him t final minus t initial, this way. So create indicator, tell him this is dt, but this will give me in seconds. If you just read the help for this one, it will give me something in seconds. dt in seconds. Okay, so if I run now, I see now that I have 301 milliseconds, 0.591. Okay, this has been rounded off to 302 using this counter, but this is more precise. It will give you more accurate, more precise, not accurate, just more precise readings here. Okay. All right. Okay, so this is this. Visual. Sure. Any question till this point? All right. Now we have two more topics to handle. Now, next topic is tunnels. Tunnels, we have already seen them. When you pass data to a structure or to a frame, LabVIEW will create a tunnel, something called tunnel. Okay. So clearly, here we can see input and output tunnels. مثلا, these tunnels, all of them are input tunnels, simply because the value is outside and you are supplying the value into your frame or your structure. While here, you have an output tunnel. Okay, all of these are output tunnels. So because you send data from inside the loop or the structure to outside indicator or controller or function. Okay, so tunnels are easy. Now how they behave in each loop slightly different. Okay, so for example, in while loop like this, I have a while loop. Okay, guys. Let's see the example here. So I want to add two numbers. It's very simple. So I have it like this, and let's take them as constants. Okay. Okay, it's just a trivial example. Now, if you wire the result outside the loop like this, automatically here you'll see a tunnel. So you don't have to create them manually. Automatically they will be created. Then I'll create an indicator. So this is my value here. Okay. This is your thing. Let me delete this code. Okay, guys. So this is the result from the loop. Now, note one thing. You know that 4 plus x is 10. Okay. So what will happen here if you run your code? You don't see any result here, right? When I press stop, you directly see the result. Okay, this means that the loop will not give you any value until it finishes. So if you pass data using a tunnel, nothing will be displayed here until everything inside the loop is finished, and then it will give you the result after the loop stops. Okay, so if you want to update the result like continuously, you have to place this inside the loop. Okay, that we automatically deleted the tunnel and then rewired everything. So here, if I run, immediately you'll see the result. Okay, sure. But if you put something outside the loop through a tunnel, no, the loop has to finish before giving you any result here. Okay. Now, if you use tunnels, let me start a new VI. If I have a for loop like this, and let's add two numbers. Let's put them as controls. This is better. X and Y. Okay. All right. So this X plus Y. Let's do this 10 times. For some reason, just imagine any code here. Now, if you wire something outside the loop, you see here is a different shape of the tunnel. Okay, simply because you have what you call tunnel mode. Like you have to specify the mode of this tunnel. If you right click this tunnel, you'll see here that you have tunnel mode. So you can select either last value, indexing, concatenating, or conditional. Okay, guys. Now, last value is the default one, the one that we have seen previously in the value. This will give you just the last value you have wired to the tunnel here, because each iteration you'll have a different value. Okay. Okay. So this only will give you the final or the last value you have sent through this wire here. Right. Now, if you have the indexing mode, now indexing simply will create an array of all of the values that you have sent to this tunnel. Okay. So for example, here you have 10 iterations. Say the first value was 5, then you added like 90, then whatever. You have many values. Each iteration will have different value depending on the input. Okay. Simply Lavi will collect all of these values from iteration 1, iteration 2, all the iterations, and will give you these in an array, as you can see here. We'll not deal with arrays now, but this method of creating arrays is very useful. Okay, so the output is an array. Okay, so, again, we will not deal with arrays, but just remember that indexing mode of a tunnel will simply give you an array. It will memorize or collect all the values. Okay. Concatenating and conditional, we will leave these, but I will mention them rapidly like this. Now, concatenation it will concatenate arrays. Okay. So here you have to wire an array. It will save array after an array. All right. I know it doesn't make sense, so we will skip them. But remember, there's something called concatenating. Conditional. Let's do this. Now, conditional, you can enable it for indexing and concatenation only. So you have an indexing tunnel with conditional input. This means it doesn't collect everything. It has to it will collect values only if you have true here. Okay. مثلا you want a list of even numbers. So here you can put a subcode to check that this number is even. So if this number is even, this is true, then it will collect that value. So this is conditional indexing or conditional building an array conditionally. All right. All right. So these are the tunnel modes. Now, here in the manual, they are mentioned, these tunnel modes, but we'll go more about them, especially the indexing tunnel, when we deal with arrays. Okay. This is just briefly mentioning tunnels. So there's no tutorial on tunnels. More will come later, inshallah. Okay, Shabab. All right. Should we stop now? Who's with me and who's not? All right, let's take attendance. Abdullah Al-Husani معنا. Joab, please, I need to hear your voice. Abdullah Al-Husani. Mona Al-Husani.
Yes.
Thank you. Ahmed Al-Khamisi. Are you with us? Nawar. Thank you. وزايد المجرفي معنا.
موجود دكتور.
Thank you, زايد. محمد المناعي.
دكتور.
ومريم المهيري. مريم معنا. مريم المهيري معنا. فاطمة المرشدي معنا.
Yes, دكتور.
Yes, thank you. عبد الله.
Yes, دكتور.
عبد الله رحمه موجود. Okay, Mariam, you are with us. محمد طنيجي معنا. محمد طنيجي. Buthayna with us. Buthayna is not our meeting. Okay, so Hajar معنا.
Yes.
Hajar وكريم. I've seen you, Kareem.
معك دكتور.
Okay, so this is this. Okay, so any question about the previous content? Last thing, we'll address the local variables. Just before we go to local variables, any question? You want more examples on any specific topic we can handle. All right. So this is this. Now, local variables are very easy. Okay, let's explain them through this tutorial. Let me close these. Okay. So for now, we did not see variables in Math and LabVIEW. Okay. In text-based, like almost everything was based on variables, right? Okay, so let's see this example. I want to create a code or a pseudocode, okay, like a fake code, in order to find the sum of numbers from 0 to 5. Okay, so what you do in MATLAB or in C++, you generate, you create a variable, let's call it sum, you initialize it to 0, right? You tell him you need a for loop for I equals, let's write a MATLAB code. Say from I equals 1 to 5. Yes.
هلا بس كنت أبدل بين التليفون واللابتوب.
معنا أحمد الخميسي. Okay. Where are you? All right. You're there. All right. Thank you. So I've initialized my variable, and I need the loop from. So here it says the sum of numbers from 0 to 5. So 0 you can exclude it. Okay, so it doesn't matter. So I equals 1 to 5. What should I do? Like sum equals the previous sum plus I. All right, and then you tell him end, and then you just show the value of sum. Okay, sure. This is how you do it in text-based. Now the problem in LabVIEW, how can you create a variable like this? There is no straightforward way to create a variable. Like everything has to be generated from a control or indicator or through wire. So the solution for this is to use what you call local variables. All right. So let's translate this code into LabVIEW code. All right. So I have a VI like this. All right. So to use local variables, you always have to link that variable to a control or indicator. All right. So to create a variable, it has to be either coming from a control or an indicator. So here let's get an indicator like this. Okay. And let's call it sum. Now to create a local variable of this indicator, you can right click and tell him create local variable. Okay, guys. So now you can see you have a local variable connected to this indicator. Another way is here from structures, you can have a local variable like this. Now this is black because it's not connected to anything. If you click, you see now you have sum, which is the label of this indicator. So this is equivalent. Now if you delete this indicator, these will come to, they will come back to be black. This means they are not connected to anything. If you click them, you will not see any possibility. They don't give you any menu. This means you don't have anything to use as a local variable. So you have to create either control or indicator. All right, like this. So let's call it sum. All right. Now to find the sum, okay, I need a for loop. Okay, for loop like this. Okay, so I'll say how many iterations do I need here? Sure. All right, let's decide this at the end. Now, what I will do first I will link this local variable. I'll put it inside my for loop. Now the algorithm says first you read the variable, add I to this variable, and store it, all of the results, store it again into sum. So to read a variable, you can see now this is, you can write to this variable here. Okay, you can always right click and tell him change to read. So now you can read the value of this indicator. All right. So here I'm going to read, add I to this, and then write back again to this sum variable. So you need a copy of this one. You can always right click, create local variable, put it again here, and then wire this one. Yes, sir. So this one will read the value in the sum, add I to that, and then write the result to sum again. Next iteration, you will read the value, add another I to this, and then write it again here. Okay. All right. So to let's analyze these values. Question. Yeah, 6 iterations. You are right, because the final value that you need here is 5. So this is 6 iteration. كنت راح أسأل السؤال كمان شوي. All right. So let's see that this works at the beginning. بعدين we will analyze the value iteration by iteration. Okay. So here at the end you have 15, because the sum from 1 to 5 is 5 times 6 over 2, 30 over 2, which is 15. Correct. This is the sum. So the value of I, let's put the value of I. Okay, first value is 0, and then 1, 2, 3, 4, 5. That's it. This is the value of I. Okay, شباب. The value of sum, now at the beginning, the value is 0, صح? So the value is 0. Next value, so here you have to find the calculation. You have 0 plus first value here is 0, and then it will write 0 here. All right. Next time it will read 0 plus 1, which is 1 here. Okay. So 0 plus 1 is 1, and to write 1 again here. Okay. Next value of sum is the previous, which is 1 plus 2, which is 3 here. To write 3. Next iteration, it will read 3 plus 4, which is 7. To write 7 again here, and next time it will read 7 plus 5, and then it will give you the result. Okay, sure. So this is iteration by iteration. So always in these questions, now this is typical quiz question, and I'll give you this code and tell you what's the final value of sum. Right, so to solve these questions, very easy. You have to build a table. Build a table like this. Okay, so let's say this is my iteration. The value of I, the value of sum, like this. So you have a table like this. All right, so you have, let's put this like begin at 1. You have the first iteration, second iteration, third iteration, fourth, and then at the end, you have 5 iterations, right? Then I have a 5th iteration. Sure, we all agree. All right. Now, the first iteration, the first value of I is 0. Second value is 1, 2, 3, and 4. Okay, Now for the sum variable, this is tricky. You have two sums. You have the sum here, like at the beginning of the iteration, and the sum after addition. So I'm going to call this sum of I, like at the ith iteration, or the index I, and sum of I plus 1. Okay, I'm summarizing this in a table, so this is taking a little bit of time, but you always can write them down directly in this code here. Okay. Okay, Shiva, are you following? This is sum I and sum I plus 1. I don't know, you can call sum I plus or whatever, I guess. Okay. All right, so first value of sum is 0. There's a trick about this, we'll come back to it, but sum is 0. Okay, so here you have 0 plus 0, this is your result. This is 0 plus 0 equals 0. All right, now next iteration, you have the value of sum is this one here. So this one will come back to here. So this is 0. You have 0 plus 1, then the result is 1. Next time, this will be used. You have 2 plus 1, which will give you 3 here. Okay. Next iteration, you have 3 plus the value is 3. This will give you 6. Are we correct this way? Right. Something is missing, so we are correct, but okay, let's see. So now, next iteration, what it will do, it will read, the value you have stored before, which was 6, it will read it here. So the value here is 6, so it will sum 4 plus 6 equals 10. Except that we have actually how many iterations we have in the loop? We have 6 iterations, right? Actually, we put 6 iterations in order to make the value of I equals 5, because I want the sum from 0 to 5. So I have some missing entry here. So this is 6, 6. This is a systematic way to solve these questions. All right? So this is my set like this. All right. Result is 10. So you take this result here and you tell him 10. So 5 plus 10 is 15, which is your final result. So final Okay, Shwab, you understand? Okay, to make things more practical, I'm going to share this note on Teams. So to access that, you go here to plus and tell him OneNote. Again, I recommend that you install OneNote. Later on will depend a lot on it. Okay. Where are we? So just wait a little bit. It should come here. Then you will see the result directly here on this OneNote. Okay, sure. All right. Any question about this? Should I repeat any point? All right. Let's run this again. You say 30. Run again, you'll see 45. Can you tell me why? Each time I run, because the result should be same, but here it keeps adding to the result. Why is that? Think about it.
The local variable is saved. It doesn't lose the data.
Yes, exactly. So basically, it will take the initial value here. It will take whatever was stored from previous iterations or previous executions. So what's the solution? And here you see each time I run this text code, it will initialize to 0. So here I missed this. How can I initialize programmatically? You have to do something before finding the sum. You must do it before doing the sum. How can we do this, Shabab? You have already seen sequence structure, صح? So basically, same way I'm writing value to the sum, I have to write a value of 0 to this sum here, صح? So here I have to create a constant and give him 0. You agree? Is this code correct or not? Yeah, here it will write 0 to the sum and then calculate the result again. But there's a trick in this code. Who can tell me the trick about this code?
0 was not read onto a variable. It was read onto an indicator.
But it's okay. I can run. So there is no syntax. The problem is in the algorithm or in the way you are coding. So you see now it's running, and you see a result here, right? But the problem is, who can tell me? Is there any guarantee that the sum is happening before this loop? Because this is what you need. You need to 0 your sum before writing to it again. So is there any guarantee that this is happening before this? No guarantee. Even if you change its location, the block diagram doesn't matter. You can put here. It's exactly the same code. Sure. So to make this, you have to use a sequence structure. Because you have to be sure that you write 0 to this sum and finish, and then you find the sum again. Sure. So what you do, you go to sequence, put this in a frame, add frame before, and then place this inside this frame. Okay, guys. So you are sure now that I'm writing 0 to my sum and finishing everything, and then I will calculate my sum again. Okay. So this is the tricky thing about local variables. They will bypass the wiring paradigm, and this will cause tricks. Especially if you see here, now I can create a local variable. Now before this trick, let's agree about this code and I'll give you the trick. Okay, so this is the way, a very useful way to use flat sequence structure. Okay, almost in all hardware applications, you will see this this scheme of using flat. Diamond here you have. I can put a label here, by the way. You can tell him this is initialization. Okay. Always the first frame is to initialize. You 0 your variables, you initialize hardware connections, like maybe here you create channels, you reset things that you want to reset, power up, etc. All of these like initialization frame. Then you do your code where you want. Okay, and often we have at the end closing frame. Add frame after. Initialization, finalization. Okay, you finalize your code like this. In your final code, you disconnect from hardware, you stop acquisition, you power off running things, stop the camera, whatever. Okay, so it's like this. This is a typical use of a flat sequence structure. Okay, guys, you understand? Questions? Okay, I'll give this trick. Okay, now here the sum, this one, you see now I'm reading and writing to the sum, but it doesn't have to be inside the same loop. Okay, actually it can be outside, totally outside the loop. Okay, so this is number one, and modifying the value using local variables. This sum can be anywhere. Okay, so many times we are using these variables, but there is no result to display. The result is internal. It's not something you want to display. So here in the front diagram, we put them away and we don't use them. So this is one down thing of local variables. They either they have to be connected to either controls or indicators. So you have to create something in the front panel, even if you don't need it. Okay. So here I've chosen an indicator, but same way. If you change this to a control, same will apply. Okay, except here I cannot write to a control, but the algorithm is still valid here. Okay, actually I can write to this control this way. So this is equivalent code. Okay, so you see the same result. Now this is it's not typical. Always when you want to display a result, it's better to use an indicator as local variable. Right? Okay. So if I delay my loop, you see now I'm going to delay the loop a little bit just to show you some tricky thing about local variables. I'll put half a second delay. Let's do it like this. Okay. So now you see you have 0, 1. So all of these are the progressive values of the sum variable. Now my code just needs the final result, so I don't need to show this. It's just to analyze these progressive results, okay, which are the results here in the table. All of these numbers here, okay. What else do I have? Now the trickiest trick about local variables is this. Who can tell me the value on the local variable here? If I do it like this, I'm writing a 0, and at the same time I am writing 3. What's going to happen? You understand the trick, Shabab? Yeah, I'm writing a 0, and at the same time I don't have any dependency between these. You write 3. So which value will be written to the sum variable? Is it 0 or 3? Yeah, exactly. This is the exact answer. You are not sure. You don't know because they're happening at the same time. This is very important. They even have a name for this in LabVIEW. Yes, but you don't know which one, Nawari, and you don't know which one is executing last. Okay, so this is called race condition. Now this race condition is tricky, and there is a solution for this, but the solution is a little bit advanced. So we will not address it. Just to mention that the solution is to use desynchronization tools. That you don't want this race condition. Okay, so basically race condition means that you are writing to a data location, an indicator or a memory or whatever, from many sources, and you don't know which one will execute before the other. There's no way to guarantee if you do it this way. Okay, so this is racing condition. It's same for hardware. If you send two different voltages to a channel, then you don't know the value that will execute. It will take. Okay, so this is again a good use for flat sequence structure. It's just to avoid these conditions. Okay, so I'm here for no reason I want to write two different values, so I'm going to delete this one. Sometimes after we finish all of the process, I have to add a final frame, which is to wrap up my variables. I have to zero. You have to zero your variables like this. Okay, this means after you finish everything, zero the variables, because this can be a motor control channel or can be a location of a stepper motor or a servo motor or whatever. So always reinitialize everything, or maybe at the beginning, depending on the nature of your code like this. So an alternative way to do this code is using this way, and you can keep this outside. All right, so this is FFG race condition is this. If you're not careful, this is very simple code. If your code is very big and you heavily depend on local variables, this becomes an issue, a serious issue, race condition. Okay. All right, Sean. Any questions? You stop recording.